mechanical system starts as an idea, a sketch on a whiteboard, a concept in someone's head. The question is always the same. Will it actually work? Working Model 2D lets you answer that question in minutes, not days. In the next 10 minutes, you will see why thousands of engineers, educators, and students around the world rely on this tool every day. If you're an engineer, you know the drill. You've got a mechanism to design, maybe a linkage, a cam system, a latching mechanism. You can do the math by hand, and that'll get you in the ballpark. Or you can build a physical prototype, which costs real money and real time. And if the first version doesn't work, many times it doesn't, you're back to square one. If you're an educator, you face a different challenge. You're trying to teach dynamics and kinematics to students who have never seen these principles in action. Textbook diagrams are static, equations are abstract. You need a way to make the physics come alive. And if you're a student, you're trying to build intuition for how mechanisms actually behave. Not just how to solve for a number on an exam, but what happens when that linkage moves, where the forces concentrate, and why a design works or fails. Working Model 2D solves all three of these problems with one simple idea. Build it on screen, press play, and see the physics happen in real time. We'll start with something every mechanical engineer recognizes: a 4-bar linkage. It's one of the most fundamental mechanisms in engineering, and it's a great way to see what Working Model can do. I'll drop in my links and connect them with pin joints. Notice I'm not writing any equations. I'm just placing parts and connecting them, the same way you'd sketch it on paper. Working Model handles all the kinematics and dynamics under the hood. Now I'll add a motor to drive the crank. I can set the speed right here, about 270 degrees per second. That's all the setup we need. And just like that, it's running. You're watching real dynamic simulation, not just an animation. Every body in this system has mass and inertia. The forces are real, the physics is real. I can pause at any point, step through frame by frame, or reset to the beginning. Total control over the simulation. But running the simulation is only half the story. The real value is in what you can measure. I can measure force, torque, velocity, acceleration, anything I need, on any body or joint in the system. I can display results as numbers, as vectors right on the mechanism, or as graphs that update in real time. And I can switch between English and metric units with one click. Now here's where Working Model really pays off. Say I want to see what happens if I change the coupler length. Instead of rebuilding anything, I just adjust the parameter and run it again. That whole cycle, build, run, analyze, refine, took about 2 minutes. Try doing that with hand calculations. Try doing it with a physical prototype. This is what our customers mean when they say Working Model paid for itself the first time they used it. And I should mention, I can also import my existing 2D CAD drawings in DXF format. So if you already have geometry in AutoCAD or SolidWorks, you can bring it straight into Working Model and start simulating full collision detection with friction and restitution. Bodies interact realistically. They bounce, slide, and mesh, just like they would in the real world. Model springs and dampers with any stiffness and damping you need. And with our flex beam capabilities, you can analyze flexible beams and see shear and bending moment diagrams update in real time. Working Model includes a built-in formula language powerful enough to build complete control systems. Let me show you what that looks like. This is a bang-bang motor controller with friction modeling and disturbance rejection, Coulomb friction, viscous damping, random perturbation torque, a switching controller with deadband hysteresis, and velocity feedback. All of it built using Working Model's formula language and interactive input sliders. No MATLAB, no external scripts, no programming. If you can describe it mathematically, you can simulate it. Record simulation data and export it to graphs, data files, or video. Share your results with colleagues, include them in reports, or use them in presentations. Beyond what the built-in formula language can handle, Working Model connects to MATLAB, Excel, Python, or your own custom programs. Instantaneous simulation data flows out to these external tools, which compute results and feed them back as forces, torques, or motor and actuator commands, all in real time, mid-simulation. And for control system engineers, Working Model functions as a plant model for Simulink, enabling full co-simulation between your control logic and the mechanical system. Everything I've shown you so far, Working Model has been doing for over 30 years. Thousands of engineers and educators rely on it every day. But now I want to show you something new, something that changes how you interact with simulation entirely. Working Model now includes an MCP server that stands for Model Context Protocol, which lets AI assistants communicate directly with the software. What that means in practice is that you can describe a mechanism in plain English, and the AI will build it, configure it, and run it for you. Let me show you. I just described what I want in a single sentence. The AI created the crank, the connecting rod, the slider, all the joints, added the motor, and set up a velocity meter, all automatically. Now it runs the simulation, and I can see the results immediately. That mechanism took me about 2 minutes to build manually earlier. The AI did it in seconds, and I can refine it just as easily. I can say, change the crank to 7 centimeters and run it again, and it updates everything. But here's where it gets really interesting. Say you have an idea for a new mechanism, and you describe it on a rough sketch. You can take a photo of that sketch, send it to the AI, and say, build this. The AI reads the sketch, identifies the links and joints, estimates the dimensions, and builds a working simulation. You can immediately see how the mechanism behaves, validate it, and optimize it. That's a powerful feedback loop that just wasn't possible before. I want to be clear about what this is and what it isn't. The AI doesn't replace the engineer's judgment or the educator's teaching. What it does is eliminate the tedious setup work, the clicking and configuring, so you can focus on what actually matters, understanding the physics, analyzing the results, and refining your design. For students, it lowers the barrier to entry dramatically. Instead of spending half a lab session figuring out the interface, they're running simulations and learning from the first minute. Working Model isn't just a demo tool. It's trusted by some of the world's most demanding organizations for real engineering work. NASA's Jet Propulsion Laboratory used Working Model to design rover mechanisms for an asteroid sample return mission in collaboration with the Japanese Space Institute. When you're designing hardware that has to work millions of miles from Earth with no second chances, you need to get the dynamics right the first time. JPL trusted Working Model to help them do that. Snorkel International used Working Model to optimize the design of their articulated boom lifts, the kind you see on construction sites reaching 6 or 7 stories. They needed to validate the kinematics of the boom linkage under different load conditions. Working Model let them iterate through designs rapidly and get to a proven solution before bending any metal. Working Model remains one of the most widely adopted simulation tools in universities worldwide. At schools like MIT, Stanford, Georgia Tech, and Purdue, students don't wait until junior year to see dynamics in action. They're building and testing mechanisms from day one, developing a hands-on intuition for dynamics that equations alone can't provide. And it's not just in the US. Top programs around the world choose Working Model because it makes the physics visible and interactive. So let's bring it together. If you're an engineer, Working Model saves you time and money. It replaces physical prototypes with a fast, accurate simulation cycle that lets you test more ideas in less time. If you're an educator, it brings dynamics and kinematics to life in your classroom. Your students don't just solve equations, they see the physics happen. And if you're a student, it builds the intuition you need to become a better engineer. The kind of understanding you can only get by watching mechanisms move and measuring what they do. And now, with AI integration, the barrier to entry is lower than it's ever been. Describe what you want, and the simulation builds itself. We'd love for you to try it yourself. Visit designsimulation.com to download a free evaluation copy of Working Model 2D. If you have questions, our engineering team is ready to help. Thanks for watching. Now go simulate something.